Problem 1691. We have a gear with a center at O and a rod pushing that. It's pinned at O at 10 meters per second. And we want to know the velocity of block B. So if this is pushing the right, this is turning, it pushes the rod here, which pushes the rod there. So to analyze rod AB, first we need to know the velocity at A. And that can be found by using the instantaneous center of velocity, because we know here at the bottom the velocity is 0. And so we can draw a triangle where this is the bottom, and halfway up at O, that's O right there, this height is 0.175, and this distance here is 0.125. So the total height from the bottom to A is 0.3. So using similar triangles here, this velocity is 10, so we can do 10 over 0.175 is equal to the velocity at A over 0.3. So using that, we know that the velocity at A is equal to 17.4 in the I direction, because that's going to be straight in the I at the top. So now if we draw the rod like so, at A the velocity is 17.14, and at the bottom it's going to have a velocity that goes that way, because as it pushes the top, this rod is going to go this way. It's going to be turning this way. As that goes down, this is going up, and the rod's going to rotate in that direction. Now the velocity at B will be in the direction of the slot, which is at 30 degrees from the horizontal. Now we can solve this two ways, so I'm going to do it both. We can do it one way without the instantaneous center, and we can do it the other way using instantaneous center. In this case, instantaneous center is a little bit tricky, so either way is probably of equal difficulty. So if we break the VB into components here, we got VB, the vector VB, is equal to VB, the magnitude VB, cosine 30 in the I, plus VB sine 30 in the J. So that, of course, equals 0.866 VB in the I plus 0.5 VB in the J. Now using the equation, VA equals VB plus omega cross RAB. So we have VA, we have VB in terms of VB. Omega is right here. It's going to rotate that direction, which by the right hand rule will be the positive K. So omega equals omega in the K direction. RBA is equal to the distance from A to B. It's got the length there, AB, is 0.6, so it's going to be 0.6 cosine 30 in the I minus 0.6 sine 30 in the J, because this is a 30-degree angle there, right there, 30-degree angle. So we can write VB. We're solving for VB, so let's go ahead and switch those two. So VB equals VA plus omega cross, we're going to do R, instead of RAB, we're going to do RBA. Because this is BA here. So VB is 0.866 VB in the I plus 0.5 VB in the J equals 17.414 in the I plus omega in the K cross RBA, which here is, okay, this is 0.52 in the I minus 0.3 in the J. So 0.52 in the I minus 0.3 in the J. And doing the cross product here, and we got omega 0.52, negative 0.3, 0.52, negative 0.3. And so we got positive this, negative this. So this part here turns out to be 0.3 omega in the, because it's a negative and going up, negative, have a negative positive, 0.3 omega in the I plus 0.52 omega in the J, that one. So now we can separate the I components. The I components are here, and we get 0.866 VB equals 17.14 plus 0.3 omega. Now let's separate out the J components, which would be here and here, and so 0.5 VB equals 0.52 omega. So VB equals 1.04 omega, or omega equals 0.96 VB. So to solve for VB, let's put that in for omega, and we get 0.866 VB equals 17.14 plus 0.96 times 0.3 . Okay, and now we can subtract that over the side, and we solve, and VB equals 29.7. And so omega, therefore, putting that into there, equals 28.5. Now we could have solved this using instantaneous centers. So if we redraw this here, we got that picture. There's AB again. Here's A. Here's B. So we need a parallel, or a perpendicular, with A is right there. And perpendicular, I'm going to draw this a little bit steeper so it fits. So perpendicular there is right there. Now that's 30 degrees. And so we know this distance here is 0.6. And we know this angle, if this is 30 degrees from the parallel, and this is 30 degrees, and that's 90, then this has to be 30 degrees also. And we know that's parallel, so we need to know that angle. And so if we were to draw this right here, that's 60, 30 plus 30. Therefore, if that's 60 and this is a right triangle, this must be 30 also. So if this is 30 and this is 30, this is an isosceles triangle. And so this is 0.6. Okay, so now we need to know so our instantaneous center is 0.6 up from the center. Now we know that omega V equals omega R, and so we know the V here is 17.14. So 17.14 is equal to omega, which we don't know, times R, which is 0.6. So omega is equal to 17.14 divided by 0.6 is 28.6. So now we have omega. Now we need to know VB. We can use the same equation over again because we know that V equals omega 28.6 times R. So this R would be R from here to here. So that distance we can find using the law of sines. So if we do the sine of 30, over 6, sine of 30 over 6, and this angle here, if that's 30, that's 30, this is 120. So this equals the sine of 120 over R. So solving that, we get R equals 1.04, and the velocity is 28.6 times 1.04, and V equals 29.7.